Our initial response to this building was wow, to be completely honest. We really want to be a part of it because one, it was a great design. Two, we think it's serving a really good purpose and it's quite a bit of a technical challenge. And builders, we like solving challenges and we like leaving a product behind we can be proud of. So not only is it a beautiful building we can walk away with a bit of pride, we also know we're giving back to the university environment.
You just felt like you were part of something special. Everyone had high hopes for the building. The brief for the Ainsworth Building was all about improving health and well-being, and that was to be evidence in the final sort of operational side. The way that we interpreted that brief was all about the actual design and the construction process as well. By using engineered timber, it was a lot more healthy place to work. It was faster, more efficient, had a beautiful aroma about the timber as well. It was a really clean, healthy site to work on.
The benefits of timber, and very much you can see in the Ainsworth building here, one is aesthetically, it's a beautiful product. You can see here what a great timber design we've got, and it's really like a great jewel in the university sort of landscape here. Secondly, there's a lot of the buildability products that add a lot of benefits. So with timber being a lightweight product, you have smaller foundations. The Ainsworth building is tight put in between two existing buildings. One's an operating hospital and one's an operating commercial building for the university. With timber being a prefab solution, we did a lot of detail work to ensure that everything came together as a bit of a kit of parts. We had less workers on site. Less workers generally means improved safety, which is great. The timber structure predominantly is an exposed structure, so the tolerance is quite tight. The builder's involvement early helps with the methodology for the building and protecting the timber all the way through to ensure that the design outcomes are achieved. We used a dedicated logistics manager to work all the way back from the design stage, ensuring that we could deliver them all the way through to programming. It really starts with the shop drawing process, and even prior to the detailing of that, it's how you actually fit the timber into containers. So every piece from the model was then put into what we call container Tetris. So every piece was digitally filled into a container, then given a number. Each piece, that number then had a barcode, about 1,000 cubic metres of timber. So it was really quite a logistical challenge for one of our guys in our team who sat there and spent most of about 5 months focusing and planning how we can do that. Fire testing of timber structures is an ongoing concern here in Australia. Thankfully, the design team here really did tackle that fire rating early and incorporated it into design, and it worked well, but it's definitely one of the challenges that needs particular focus.
Ultimately, the structure is a functional item, but when it's so beautiful, like mass timber is, it's treated as though it's a piece of joinery, and the client wants to see it represented in that beautiful way as well. So it's a real kind of hybrid where the structure in this case, because of its beauty, so heavily informs the architecture. It's like the whole thing is this piece of carpentry.